Spaghetti. So today we're going to be going through our class feedback for our assignment. So first thing I want to say, congratulations, everybody finally figured out how to put a title page on, huh? Very impressive. Now, one thing that we need to correct straight away is some of the stuff about your tables. Now, initially, when I got you guys to complete these tables, I forgot to get you to change the cells that are in here. So all you need to do is go to the top cell, enter in what your function is. Now, you know what your function is based on your assignment. Make sure that instead of having T in there, you select the cell to the side here, press enter, and then if you click on that one, hover above the side and you'll see it turns into a black cross. All you need to do is pull that down and it will drag that code. Okay, so you'll need to do that for FT in the polynomial model, the FT in the exponential model, and the FT in the trigonometric model. Now, the reason why you need to be doing that is because this is the prediction of how many subscribers you're going to have based on the polynomial model. So it's saying at the end of your first month, you'll have 5,157 K subscribers for this one, or at the end of the 11th month, you'll have 5,509 subscribers. Okay, so you want your model to also make a prediction about how many people will be subscribed. Now, we're going to go through the task because I can definitely tell that some people are not 100% sure about what the task is about. So, I will not be sending you this document either. It's too much assistance for me to send you the document, watch the video. Ta-da. All right, so your task here. Now, I want you to think about it like I am just a lowly YouTuber who, went through school without doing anything and now I just put makeup on my face. So I need you, as my brilliant mathematicians, to go through and do an analysis of my channel for me because I, as the lowly YouTuber, cannot do it for myself. I need you to tell me about not only how many subscribers I'll have at the end of each month, I need to know the speed of the increase of each subscriber, and I also need to know the acceleration of the channel so that way, when I go out and I'm trying to get, my free makeup and my merch and stuff, I can try and get advertisers to sponsor me, things like that. So I need you, with your brilliant brains, to use your knowledge of calculus to do this. Now, a lot of people have talked a lot about regression in the assignment, but regression is something we explicitly looked at in year 10 and 11. Okay, and that was we used regression to evaluate whether or not models were good. Now, in this one, we're not really worried about regression. We're worried about calculus. We want the speeds and accelerations. So, that's what we're looking at more. Now, we're just going to flop back to my tables over here and talk more about what each of those things mean. So, like I was saying, this column here tells you how many subscribers there are at the end of each month. Pretty easy, pretty standard, you get that, okay? It's gaining each time, so I'm expecting the numbers to get a little bit bigger each time. Now, the speed of your subscribers is not just, 32 subscribers are joining per month, which is what the speed is in this case. But think about it like if you're in a car, you can be traveling at 80 kilometers per hour, but that doesn't mean that you've traveled 80 kilometers in total. Okay, so your speed here is more about your growth of your channel. So here you can see my speeds are all positive. Every month, my channel is growing by a couple of subscribers. Wait, I just realized that this should have been 32 the whole way down based on my function. Yeah. Let me just drag that. All right, whereas if you look over here, the speed of this one is 478. Now, that's because your exponential model rapidly increases. Okay, these speeds are not realistic. They're huge. All right, there may even be a problem with my model somewhere. Whereas these ones over here, again, they're looking more reasonable, but see how they fluctuate a lot more? So here, it reaches a certain point, and then my speed becomes negative. Now, if you end up with negative speeds, that means that you are losing subscribers at that point. Okay, you're no longer increasing in speed. You're not gaining a certain amount of subscribers per month. This month, I would be losing 33 subscribers. Okay, don't forget to use your units when you're talking about this. I'm omitting mine just as I'm doing this example for you, but you need to talk about the units too. Okay, now we're going to talk about acceleration. Now, if you are accelerating, that means you are gaining speed with how quickly people are subscribing. Okay, over here, it's the same the whole way through, so it's 0. That's fine. That makes sense. Okay, if you look over here, I start off by increasing in acceleration because it's getting faster, and then it hits a point and my speed starts to decelerate, which means that I am now losing, or like it's going down in acceleration. Okay, and then at some point it comes back up and it starts gaining again. So that's not really realistic for this case. Let's go back to our thing now, and we're going to talk about this more. So again, we don't care about regression. Now, assumptions are things that make your assignment make sense. Okay, so here, a lot of you have added in stuff, which is fine, but some of you have just been making statements for the sake of making statements. Now, when we talk about an assumption, for it to be documentation of an assumption, I need to know explicitly how it affects the models. Okay, if you're telling me that you think your YouTuber is going to start trash talking someone, and then a whole heap of people are going to unsubscribe, that means that the growth of the channel is no longer related to like what the person's done in the past. You're expecting something erratic to happen which cannot be predicted in the future. Something like that. It's about how it's affecting the model. A lot of people are making very vague statements too. You need to be explicit. This is happening. This is what might happen in the data. Because then later on you can say if you saw that or not. Okay, so the other thing, you want to explicitly state an assumption about what is a reasonable growth rate. Now over here, I'm not going to look at my exponential model. Again, I'm thinking maybe something's gone wrong with that one. I am going to look at my trigonometric and my polynomial. Now for this one, because I chose Tanamojo, and she has been trash talking, she did get a little bit of a decrease at some point. Now, it would be good in my observations to go through and analyze what happened at that point of decrease. Why did she start losing subscribers? You chose these people, which means you probably watched them. Or you could Google them, or you could look back at their library. Did they stop posting videos for a while? Did they start posting bad videos? Did they have a fight with another YouTuber? All of these things you could talk about. That could be an observation. Okay, so you need to assume your maximum number of subscribers possible. Now, I would relate that back to your asymptote. So for me, I'm going to say that the max number possible is 6,000. And I'm going to say that that's because, you know, there's only so many people in the beauty community that might want to watch this person. You're only expecting that the model will be good for this amount of time. Whatever. Just pick a reason and roll with it. And you want to assume your speeds and accelerations. So based on this, I would be looking here. I would be looking over here. Now, you're not going to put this in your assumptions. You're also not allowed to refer to this until later. Okay, at the moment, we're only looking at it so that you can make an assumption, but pretend like you haven't seen it. So I would say that a reasonable growth rate for my assignment is going to be anywhere between maybe about 25,000 subscribers per month to maybe 50,000 subscribers per month. Okay, that sounds reasonable for my person. Now, per month, I'm talking about speed. For the acceleration, I would say that a little bit of deceleration could be possible for my person because they've backtracked. And so maybe the lowest I would accept would be -10 acceleration all the way up to about maybe 20 acceleration. Okay, having that in your assumptions allows you to look at your data and then later on say, this isn't reasonable. Okay, if I make that as my assumption, I look here at this acceleration that exceeds 20, so that model is not reasonable in that position for the acceleration that we would assume is reasonable for this person. Now, either that means your assumptions are off, or it could also mean that your assumptions are off, or yeah, the model is just not reasonable at that point. Okay, now the other thing that I would suggest to do in your graph is I've added on some extra months. So all I did to do that was I went to my data, hovered in the corner, or, highlighted this whole thing here where I've got all that code, and then I just dragged it down. Now, I did that so I could make predictions later on. I can observe, okay, maybe after another 4 months, here's what's happening. Is it still reasonable in the future? Part of this is your YouTuber wants to predict the future and see what their growth and acceleration is. It's pretty hard to complete this assignment without making the table extend and then referring back to those predictions, which a lot of people have tried to do, but you want to refer to them. So all you have to do, put in the table, drag it down.
What if you don't have a table and you just do a calculation of
then you just chuck it in a table, drag it down, throw it in the end as an appendix. One other thing while we're in here, if you go to view and you change it, sorry, not view, formulas, show formulas, it changes it to look like this. You just copy and paste this into your appendix to show that you did this in Excel and your formulas were correct. Because I have had people before who've gone in, worked all of these out by hand, written the numbers in here, and then gone, wham, bam, thank you, ma'am, I've done a fantastic job. But that's not quite what we want. We want to make sure that you're using technology appropriately. Okay, I'm just going to make sure this is recording. Yeah, we're good. Okay, so let's continue. So, solve step. Now, a lot of people have just done stuff. You need to explain what you are doing, why you are doing it. So for my solve step, I would say I am going to now input the data in Desmos, and then I will use Desmos to generate a polynomial model. Okay, what you're doing, why you're doing it. Go to the next step. After I've created my polynomial model, let's say this is it, I would then say, looking at the polynomials, the cubic or the quintic. The quintic has a better regression score than the linear line, but the linear line is probably more likely to predict the future. Okay, so in this assignment, I will then be using the linear equation. So your regression doesn't have to be the one that you use. If you've already chosen it, that's fine. You can stick with it. You just say, I am choosing to stick with the, oh, I'm choosing to have a polynomial of the second degree, whatever, because the regression score is higher. That's a valid reason to pick the model. You can also argue against it based on the future. Another valid reason. Okay, so I've got my polynomial model. These should all be 32s, remember. So when I'm looking at this model, I would start to evaluate what I found here by saying the polynomial would suggest that we have a constant speed of 32 subscribers per month. This is zero acceleration for the model because it is a linear line. Something like that. Doesn't have to be too fancy. You're just identifying the fastest and the slowest one. These values fall within our acceptable tolerances for our models. Therefore, could be a reasonable model for this assignment. Could reasonably predict the future, something like that. Next one, exponential model. Make sure that you justify your placement of the asymptote. I don't care where it is. I just want you to tell me why it's there. Right? Even if your models kind of look skewiffy, unless they actually look wrong, I'll take them. Whatever. I don't care. Okay, so then same thing happens here. You'd state your fastest and your slowest your fastest and your slowest speed. I'd state whether or not it's reasonable. I would then look at my fastest and slowest acceleration. Is it reasonable? I would look at what's happening in the future growth. I would state whether the future predictions are also reasonable. This one is probably not. Therefore, I would say this model sucks. But again, like I mentioned, I think there's an error in what I've done in Excel. So yours will probably look different to mine. Next thing, trigonometric model. Again, you state whether, is it sine or cosine? Why is it that? It's definitely not tan. Okay, then the other one, you talk about why you've placed your period at the length that it is. Again, I don't care why you chose it. I just want you to tell me why it's that. Then you go through. You talk about your speeds and acceleration. What's the highest? What's the lowest? Is it reasonable? Look at your predictions for the future. Do they make sense? Those little evaluations where you're talking about, is it sine or cosine? Where's your asymptote? What's your period? That will probably make up your discerning judgment for a lot of you. So it'll be that descriptor. If you don't put it in your assignment, you probably won't get that dot point. Next one, evaluation and verification. So when you're comparing the models, if you've done as I've said and you've compared them throughout, then you don't need to write a statement for each one saying, for polynomial, the fastest speed was this, the lowest was this. You can just compare them all at once. So you could make a statement like it says on your draft checklist, down here, makes comparing statements. The polynomial model predicts this, this, and this. The growth and acceleration would be this compared to the model of that. This is a difference of this much. The polynomial model is far more superior than the exponential model because it is realistic compared to the unrealistic growth. Rah, rah, rah. The other thing we're going to do is, when you're talking about the reasonability, you may have already done this throughout your assignment if you are talking each time about whether or not your speeds and accelerations are reasonable. So this may possibly be embedded throughout your assignment, but what I do need you to do is read on your draft checklist where it's got the evaluate and verify, the evaluation. So refer back to your assumptions and state if the findings are reasonable. If you've done it throughout your assignment, you can do it in a sentence there. Okay, the only models that are reasonable are these ones because of this. Refer back to your observations, go back, talk about whatever you made in the observations, link it back to your findings of the assignment. Don't just restate the observation. Okay, it actually has to be affected by your findings in the assignment. Next one, makes statements that link back to what you found in the task, evaluate whether the outcome is reasonable / it is possible. You might find that all the models are terrible for future growth. That is fine. Okay, if that is your finding, you'll fix it up later in the limitations and improvements. Next one, your strengths. You'll comment on how well they match the original data points. You'll comment on the ones that have good speeds and accelerations. They're the strengths you want to talk about. Okay, whether you think they are good to estimate what's going to happen in the future. That's what you're going to talk about there. Now, limitations and improvements is a good one. It's a spicy one. Okay, let's talk about what your models actually look like. Now, with this straight line here, the green line, that's my linear model. There's not really many improvements that you can suggest to the linear model, but you can suggest improvements to the exponential model on this one that I've got in front of me. Okay, so I set my asymptote to be 6,000. If you change that asymptote to be like, I don't know, 500, not 500, whatever that top coordinate is there, then it might fit that shape better. So you could adjust some of the variables to make it fit the shape better. But I want you to tell me what adjustments you're proposing to the different variables to make those changes. If you're changing the asymptote, then I'd be saying something like the b value in the exponential model will be adjusted to create better alignment with the shape. Okay, if you're talking about your trigonometric model, now I'm going to draw this on the board. Your classmates are going to write this on something, anything, I don't care. But if you were away today, you can ask them for it. So, if I was going to talk about adjusting this as a trig model, I might say grab it here, grab it down, and then instead of using this as my minimum, maybe I take it as my mid. You know, the effect that that's going to have, if I take it as my mid, it's going to shoot it up like that. I can also take this point as the midpoint, make this a minimum. That would change this graph from being whatever you said it was to a minus cos graph, where this is going to be my D value, that's going to be my A value, but that would force the shape to take on a straighter line. Now I'm bringing this one up because I know a lot of you will probably have that as your issue opposed to mine because, let's face it, Tana Mojo picks a lot of fights. Okay, what else? Conclusion. Your conclusion doesn't need to be long. State which model is the best. State that you have satisfied the requirements of the assignment. That's pretty much it. Now, a couple of you will probably have some trouble with word count for this. You can always make sure you save your assignment first. Save your assignment, go back through, delete the contents page, delete all of your pictures and tables so that it's not including the captions, delete your appendix, see what the word count actually is. If you do that and you work out that your word count is valid, say you work out your word count is 2,000, but the count at the bottom of the page is saying 3,000, I would just do this. Word count, excluding, you know, all of those things. And then I would say, wait, wink. Don't pick 2,000 exactly, okay?
Pick.
I'd say, you know, how convenient for me. I'm just under. You don't lie about it because they will stop marking if your assignment looks unreasonable. But if you think that you're probably under the word count but your tables are bulking it up, just go through, delete everything, see what's left over. Paul reckons he did it and he's had 2,400 words initially and it went down to 1,300. So...
I was excluding, I haven't finished.
Oh, yeah, Paul, I know. You haven't finished. I know. I am aware. Yes.
Do equations and
No, they don't. Delete them out. Chop, chop. Snip, snip. Baby. Anyone else got questions that they want to ask? Yeah, so your equations will come up as a word, but you don't. It doesn't count towards your word count. Yeah. So I'm saying when you're completely done, if you just want to check your word count, just make sure you save it first. For the love of God, save it. And then save your one that you're going to delete everything as, like, deletey McDelete face.
Copy it to another document.
Yeah. You could highlight the paragraphs.
That's more complicated.
If you press Control and highlight stuff, and then you scroll up and you keep holding Control, you can highlight stuff, and it will only count those words that are highlighted. I feel like Paul's way of just deleting everything is easier, as long as you save it first, for the love of God. Save it as something else too, so that when you've deleted everything, you don't accidentally press save, and then you're like, oh, this camera's going to kill me. Okay, that's it. It's 11 o'clock. You've got 45 minutes. Fix your tables first. So go through, input your equations for it, drag it down, and then drag it down to make the predictions. Okay, copying and pasting over the top of your old tables will take you 2 seconds. That's it. I look forward to you rewatching this later.